In this video, we'll talk about parameter sweeping and behavior space in NetLogo. Parameter sweeping is the process of investigating the effect of a parameter or variable by sweeping through the range of values that parameter can have in your model. Parameter sweeping is useful for evaluating the sensitivity of a model to the variables or parameters being evaluated. It's also useful for finding the optimum value of a parameter and for exploring the whole landscape of potential outcomes obtainable from your model. BehaviorSpace is an integrated NetLogo tool that allows you to perform a vast number of experiments using your model in an automated manner. It runs your model, systematically varying the model's parameter settings and recording the results each time the model is run. This allows you to perform parameter sweeping automatically and to develop an understanding of the landscape of possible outcomes obtainable from your model. Let's look at an example. We'll be using the wolf-sheep predation model found in the NetLogo library under Biology. So here's the interface tab of the wolf-sheep predation model. You can see that the model is rather complicated, but we will only be varying a few variables in this example. So to open BehaviorSpace, we go to Tools and then down to BehaviorSpace. This opens the BehaviorSpace window, which is currently blank because we've run no experiments using this model before. If we had run experiments using this model, then there would be experiments listed here. So we're going to press New. This opens the experiment setup window. And we can see that there are a variety of things that we can change in this window. First, we're going to change the experiment name, and we're going to call it Wolf Sheep Experiment 1. The next box, you can see that there are variables that we can change. These variables are the same variables that appear on the Interface tab, and they appear as either sliders or as switches. So we will be changing the following parameters in the model. The initial number of sheep are going to change. Now, there are two ways that you can vary the parameters in your model. One way is to set the specific values of the variable by listing them in a row. And that's what we're going to do in this case. So I want to have the initial number of sheep be 10, and then 50, 100, 200, and 250. Now it's important to know what the range of values are in the slider, because if you go out of that range, then the experiment will fail. Another way to change the value we're going to use in the grass regrowth time. Now this variable, here it is, the slider for it is here, has a range between 0 and 100. So I would like to explore that range in increments of 25. So in order to do that, I need to use another set of square brackets inside, and I will put the initial value that I want, which is 0, and then I'll put the increment that I want to use, which is 25, and then I'll put the final value, which is 100. So you can see that I have another set of square brackets inside the square brackets for grass regrowth time, and that I've put the minimum value first, the increment second, and then the final value third. Okay, so now we go down to the repetitions box. Now remember, we use random numbers in our models, so the results from the model can vary a lot from run to run, even if the same variable settings are used. So you want to run the model more than once at each combination of settings so that you can see what this variability is and take an average. In this case, we're going to use a repetition of 10. That means for each setting of variables, the experiment will be run 10 times. The next box is called Measure Runs Using These Reporters. All that means is that's the output you're going to get. So in this case, it shows the default of count turtles. In the wolf-sheep predation model, we have two breeds, wolves and sheep. And so if we do count turtles, what that will do is give us the value of wolves plus sheep, because those are all the turtles. What we want is we want to see how many wolves there are and how many sheep there are separately. So we're going to change that to be count wolves, and count sheep. This next checkbox, measure runs at every step, means that it's going to provide you with all the data that the model is generating. So you'll get the step-by-step values for your model. This is commonly what's used. If you uncheck this box, you're only going to measure each run after it ends. So in these next two boxes, you put the setup command and the go commands. Usually when we create a model, it's setup and go, and in this case, it's also setup and go, so we will leave those alone. Then we have the stop condition. So this is the condition that will be used in order to make the model stop. In our case, we want the model to stop when all the turtles die. So we're going to use the command not any turtles. And then there's a box for final commands, and that you would use if you had some command you wanted to run once the program was over. In our case, we don't have any commands that we want it to run. Now, there's a time limit too. That means the number of ticks, the maximum number of ticks you want to use. If you think there's a condition under which the model would just keep running indefinitely, so say, for instance, in the wolf-sheep predation model here, if all the wolves die, there is nothing to kill the sheep. And so the model would run indefinitely. Or if your model reached an equilibrium where the sheep and the wolves were perfectly balanced, then the model would run indefinitely. So we don't want the model to run indefinitely, and we're going to choose 1,000 ticks just so the model will run relatively quickly. If I were running the model for data purposes for research, I would probably run it for a longer period of time. Then you click OK, which is at the bottom of the screen. Then you get the BehaviorSpace box opened again, and you can see that your experiment is listed there with how many runs of the model are going to be performed, 250 runs. And you click Run. Now it's giving you an option here of how you want your output. You can either have your output as a spreadsheet or a table. When you have it as a spreadsheet, it's much easier to read. The table output is if you were going to import it into a database or a statistical package. So we'll leave it at spreadsheet output. And in the case of my computer, I'm going to be able to run 4 runs at the same time. This will vary according to what kind of computer you have. Then I'll click OK. It's asking me where I want to put my output. So I'm just going to put it right here. And here we go. Now you can see in this case there are no wolves left, so luckily we've told the model to stop at 1,000 ticks, which could take some time. Well, I'll let the model run until it's done, and then I'll show you what the output looks like. So let's take a look at an output file. The output comes in the CSV format, which can be opened by many spreadsheet programs. I have it in Excel here now. The first 4 lines of the spreadsheet contain the information about the version of NetLogo used, what NetLogo program was used, what experiment was run, and the date and the time. The next 2 rows, the dimensions of your world, and everything after that is data. Row number 7 shows the run number. So we can see here run 1, run 2, run 3, run 4. You'll notice there's 2 columns for each run. That's because we had 2 output values we were looking at, the number of wolves and the number of sheep. So we need a separate column for each one of those. The first few lines show what the values of the input parameters were for each run. We can see that run 1, run 2, run 3, run 4, all the way through run 10, since I did 10 repetitions, will have the same input parameters. If we go down, we can see that after run 10, in run 11, we've changed this value here, which was the grass regrowth time, from 0 to 25. and that's what's changed in run 11, then that same set of parameters will be used from run 11 through run 20, and so on. So you can see the data set is rather large. There were 250 runs, so there will be at least 500 columns of data, and they run up to 1,000 points down. But don't let that overwhelm you, because most of the time what you're interested in is the final number, which is given here. So we can see that the final number does vary from one run to another. It doesn't seem to vary very much, but then on run 4 we end up with 0 sheep. So in run 1 we have 0 wolves at the end and 7,564 sheep. And that continues until run 4, in which case we have 0 wolves and 0 sheep. So you would want to average the output values for the 10 repetitions of each set of input parameters. And then you could analyze that data. Or you could plot some of these time curves, which would be the same as the time curves that appeared in the NetLogo interface tab. You could analyze the data in any way that you would like. So, in summary, parameter sweeping allows you to investigate the effect of all the parameters in your model on the output from your model. And BehaviorSpace is an integrated NetLogo tool that allows you to do automated parameter sweeping. Thank you.